So this lecture is on the sine law and the cosine law. And our minds on section starts with a triangle. And what we should notice from this triangle is that it's not a right angle triangle. This is a scalene triangle with no right angle. So we can't use our primary trigonometry to solve this. However, if we do some geometric manipulation, we can actually solve this using primary trigonometry. So let's drop a perpendicular line down from B to line AC. In this case, we would have two triangles, two right triangles. The triangle that has a hypotenuse of BC, we can solve for the height using what looks like cosine, because cosine of 48 would be x, or the height, over 13. Sorry, I guess that would be sine. Sine of 48 would be the height over 13. And once we have that height, we can then use the sine of 27 to find out the hypotenuse AB, or x, on the other side using that height. However, this requires a little bit of extra steps, and there is a different way of doing this. When we have a triangle where we have two angles and a side, we can use the sine law to solve for that triangle. In fact, anytime we have an angle-side pair, or we can easily calculate an angle-side pair, we can use the sine law to solve for any other side or angle of that triangle. Now, the sine law is written usually as a triple equation. So we have we have A over sine A equals B over sine B equals C over sine C for any triangle ABC. Or we can write it as sine A over A equals sine B over B equals sine C over C. Either way is fine. These are what we call triple equations. So it's actually three equations in one. The first equation, I'll see if I can highlight this. The first equation is this one here. A over sine A equals B over sine B. The second equation would be this one. B over sine B equals C over sine C. And the third equation, if we can imagine, it's this here. A over sine A equals C over sine C. That's our third equation. So that's how a triple equation works. Rather than writing three equations, we just write them in one line like this. So this is our relationship. On what we could do with this sine law is solve for sides. This makes it easier to solve for sides, and this version of the sine law makes it easier to solve for angles. So we're going to do an example of each. The first here, we have a solve for a side question. We're trying to find this x. And we have an angle side pair of angle A and side A. So we're trying to solve for this x, which is actually side C. So what we do is we write our sine law as C over sine C equals A over sine A. And then we replace our variables with what we know. So x, the lowercase c is actually the x. Angle C is 40 degrees. Side A is 8.9. And angle A is 21 degrees. And then we rearrange this by multiplying this denominator to the other side of the equation. And then we evaluate. And lastly, because this says to the 10th of a centimeter, we round it to a 10th of a centimeter. Now let's use the sine law to find an angle. So here, this angle is the angle B. The opposite of that is known, that's lowercase b. but we have an angle side pair of A. So here's angle A, and here's side A. So we write this as sine B over B equals sine A over A. We replace each of those variables, and then we can multiply the right side of the equation by the denominator of the left side. Now this is an important step. Because this is what sine of theta equals, we need to find the inverse sine of that calculation. So I'm going to do a sample here by putting this in the calculator, just so you can see how all of this can be put in the calculator. And your calculator that you're using might be a bit different than this one, but as long as you understand how your calculator works and you're consistent with it, you'll be able to solve these problems. So first, I have 37, and I want to find the sine of that. So I type in 37, then I press the sign for this calculator. Then I divide that by 13.2, and I multiply it by 17.4. At this point, I can hit the equals button, because this will give me what's called the argument of the sine of the inverse sine. So now I have this value. I need to find the inverse sine of it. So I hit my second function button, I hit the inverse sine, and end up with 52.495. And this rounds to 52, because we're rounding to the nearest degree. Now there's another law in trigonometry. This one's called the cosine law. And for the cosine law, we can use this whenever we have all three sides of a triangle known, but none of the angles, or we have an angle and the two sides adjacent to it, but no angle side pair. So there are two ways of writing this as well. To solve for a side, this is the method that's used. And to solve for an angle, we write it this way. Now again, this isn't written as a triple equation just because we don't have the ability to do that, but we can replace C with any other letter here. So we can write this as C squared equals A squared plus B squared minus 2AB cos C, or we can write this as A squared equals B squared plus C squared minus 2BC cosine of A, or we can write it as B squared equals A squared plus C squared minus 2AC cosine of B. And that's the same for this here. We just have to be consistent in replacing it. And I'll show you that in the first example. Here we have, it says to determine the length of side x to the nearest meter. And we would write this first as, because we're solving for side A, which is x in this case, we write it as A squared equals B squared plus C squared minus 2BC cosine of A. And then we make our replacements. So A is x, B is 156, C is 78, and cosine of A is 134 degrees. Now we know that x squared would equal this. Looks like I repeated that line. So we need to find out what the x is. So we find the square root of that. And this can all be put in your calculator at once. So I'll show you how to do this as well. I'll first start off by putting brackets, because I'm going to need to do the square root of this at the end. And I'll put in 156 squared plus 78 squared minus 2 times 156 times 78 times the cosine of 134. I'm going to close the bracket, and then I'm going to find the square root. And I get 217.54, which rounds to 218. Now to solve for an angle, I know all three sides here, so I'm asked to solve for angle B. So I write this as cos B equals A squared plus C squared minus B squared over 2AC. I make my replacements, and then I find the inverse cosine of that. So I'll start this by first writing a bracket, and then I type in 4.13 squared plus 24.1 squared minus 58.4 squared. I can close the bracket because that's my numerator. And then I'm going to divide by bracket 2 times 41.3 times 24.1. I'm going to close the bracket, and I'll hit equals to evaluate that. And then I need to find the inverse cosine. So second function cosine, I get 124.38 or 124 degrees. So I'll do 4 more of these. I'll do one of each of these questions. Let's start with, we'll do 1C. So 1C, we're trying to solve for side C. And I know the angle side pair for B. So sine B, or rather I would write this as B over sine B equals C over sine C. So B is 2.3 over sine B, which is 18 sine. And then I multiply by 83 sine. And I should have for C 7.4 meters in this case. Let's try 2A next. So here I'm solving for an angle. I have an angle side pair here. 16 and 41 is the angle side pair for C. So in this case, I would have sine of B over B equals sine of C over C. And that would work out to sine of theta over 28 equals sine of 41 over 16. So I'll write this all out. I'll find out sine of 41 divided by 16 multiplied by 28. And then I would find the inverse sine of this. And that's actually not calculable because there's a bit of an error there. So I'll have to fix that. So when you do this question, you'll see a different problem here that will be solved using the same method. For 3, we'll do 3B. And 3B, we have a side 8.4, another side 9.4, and we have the angle between. So we would use the cosine law. So this would be 8.4 squared plus 9.4 squared minus 2 times 8.4 times 9.4 times the cosine of 34 degrees. And then I would find the square root of this. I would get 5.3 kilometers. That would be my length for A. And lastly, I'll do this problem here. So in this case, I have to write this as sine of C equals A squared plus B squared minus C squared over 2AB. So I will start with my numerator. It's going to be A squared, 7.3 squared, plus B squared, 5.4 squared, minus 7.8 squared. That's my numerator, so I can close the bracket. Divided by my denominator, which is 2 times A times B. I can hit equals. I need to find the inverse cosine of this to find my angle. So angle C in this case would be 74 degrees.